It was really just, so it was just kind of a logical reasoning thing. There was no specification or input from customers. It just kind of seemed like, what's a reasonable time and a reasonable number of rentals, and they kind of equated out to about that time frame. So we're selling it for $1,500, which is a 5x multiplier on the cost of the parts, roughly, right? So included in that 5x markup is your labor, your overhead. So your profit margin isn't 300%. It's
so usually I multiply by pi with the cost of materials.
Okay.
So using that, you're probably at about $1,100, $1,200 for your total cost, activity-based costing.
So multiplying it by pi gives you your total cost?
Yeah, usually. Well, at the lab, we have a different structure.
Sure.
But, that's what I usually take when the scientist comes to me with a proposal.
Okay.
And he's usually off by pi.
Okay.
And the difference between the 3 and the pi is essentially a little bit of contingency that things that you forget. So usually you're in consistent with the scientist at the lab. I'm not sure if that's a compliment or not, but you're consistent with them.
Okay, good. So that gives you a $300 to $400 margin on.
Yeah. So I think you're still okay. The margin starts to get a little tight. Some of your venture capital guys might kind of bristle a bit at the price versus the profit, but it's reasonable. It's reasonable. It's not meant to be a criticism. Your logo is very nice. I think this is one of the first projects I've seen with a logo. There's been other ones, but this is really nicely done. It looks like a professional job.
Thank you.
So back to the criticism.
That didn't take long.
Well, it's got enough cable for 50 feet, which is longer than any staircase on a single flight that we know of. So any staircase that you might have that's straight, it will be able to handle it.
Okay.
No, we weren't able to because of our issues with the track alignment.
Okay.
So that was our major restriction there on determining cycles to failure.
Right.
So without some empirical data, I don't know how fast the tracks would wear. The manufacturer didn't publish anything on the winch, and so it would really have to be attested.
Yeah. So that's something you either go out and calculate with some data off your runs or whatever, but it's kind of something out there for it. Okay, that's all I have. Nice job.
Thank you. Thank you. It was looked at, yes, but it wasn't a major concern because all the parts were sufficient enough that it wasn't an issue.
I'm not sure what you mean by failure analysis. You mean
What failure analysis requires you to say, all right, what can break, what can fail? If it fails, what happens?
okay?
Does it create a safety problem?
So we didn't formally do that. I think we all kind of know a few things in our head that problems that we encountered while we tested, what could go wrong. If a track breaks, what happens? Well, it kind of clunks down on the stairs and it's stuck. You got to take your load off of it. I assume that's what you mean. But we didn't formally do a study on it. No. Oh, the anchor? 30, was it just over 30 pounds?
Yeah.
And so we did a couple of things. So our original plan was to buy a piece of plastic to build that out of.
But plastic will be very slippery.
Well, so it has a rubber mat on the bottom. So wood's not very frictiony either. So we put rubber matting on the bottom for friction. So what we originally intended to do was use plastic. Unfortunately, for prototyping, a large piece of plastic to buy and machine is costly. So we used wood because wood's lighter than metal and a lot cheaper. So in what Dodge mentioned in our future plans is ideally we would make a plastic injection molded platform, with ribbing, so it's mostly hollowed out, and then you put the rubber matting underneath that so that you still have the grip, but it's a much lighter thing to carry up the stairs.
It's all dependent on the load that you're trying to carry the stairs. Obviously, if Mary Ellen wears down the top of the stairs, you wouldn't be able to pull it that weight. But when you're moving heavy objects, so if you put a full 400 pounds on the dolly, after you get it off the dolly or how you get it on the dolly, you're going to need multiple people to do that. So you could have multiple people stand on top of the stairs to get the force required to keep the platform static.
The other thing that I think you may not see because it's not put in that format. So in our notebooks, we have some hand sketches, right? A little free body diagram, and you've got your friction force and your down force and your, the force of your cable, which is also providing some down force on your platform. And so the only thing shown in the presentation is the SolidWorks simulation of that, right? The motion study checking the slip. And so that takes into account all the forces that are involved there. But yeah, we didn't include just a vector diagram of what that looks like.
It bobs a little bit, but we would change the pulley located at the top here so that the tension in the cable would keep it along the plane, that it wouldn't tip over due to a very rearward CG.
Because as it stands with the way that the tracks are oriented, right, because the track is here, if you manage to get all of your weight down there, yeah, you start to get a little tipping up as it rides up the stairs. Does that make sense?
Yes, it does.
And I think that's what you're asking, right? Or yes, that's what we were talking about with the vector analysis in our notebooks, which Dr. Lumia has now. We have the hand-drawn sketch of that, some hand calculations, but then what's shown in the presentation is the motion simulation, where you see the study done in SolidWorks simulation package, where we put the 150-pound downforce, the 400-pound load on the cable, and then the coefficient of friction of the rubber on the concrete in there.
Okay. So is that about what a refrigerator weighs?
Yeah, that's what we based it on, was kind of an average refrigerator weight.
60 pounds is kind of the break-even point in terms of if it's worth to lug up the stairs. Like, obviously, if you had something heavier, it's going to be too difficult to lift by yourself, and anything lighter is not going to be strong enough. It's not going to be able to have a safe frame. You include an owner's manual.
Well,
laminated sheet of plastic that says these are the simple rules of how to use it.
yeah, you do the 1, 2, 3 setup or something like that. There's a couple of things, like Dodge mentioned earlier, the pulley system to maintain the alignment of your winch cable is something that certainly needs to be improved. Once the cables are robust, that should be sufficient. Beyond that, it really is just kind of a 1, 2, 3. Make sure you set it up right and stand on the platform.
Great, thank you.
Any other questions? Thank you.